My name is Roeland Kindt. I'm a senior ecologist with CIFOR-ICRAF and wanted to briefly introduce some of the tools that we have for species selection. Now, one of those tools you can see behind me. It is an interactive vegetation map that covers the whole of Africa, and it allows users to select indigenous tree species for a variety of purposes, including different products and services. And later in this session, we will be demonstrating the Afrikaa Tree Finder, which is a mobile phone app that we developed for relatively simple and affordable smartphones available in East Africa. And it's an easy-to-use app, also used to select tree species. And on the website that is accompanying this event, you will find a larger range of databases, apps and maps that people can use to select suitable species, what we call the right tree for the right place.
Afrikaa Tree Finder is a data dissemination app to deliver information regarding potential natural vegetation based on users' location. The app is released in Kenya and Uganda. When the app starts, user sees potential natural vegetation map, the one they have downloaded after installing the app. Users need to press GPS option to identify location on the map. Once GPS gets fixed location, users can proceed by zooming in on the map to see their location. The next step is to see the type of vegetation available on user's location. On this screen, users need to select the purpose of planting trees. Here I am selecting environment as one of the future usage of my trees. Users can refine their tree usage by further selecting the sub-usage options. I will select soil conservation. Since the app is released in Kenya and Uganda, thus we have provided the tree species names in local languages as well. However, I will use English to see scientific names. Once the language is selected, app shows a list of species based on user's location and selection criteria. I can select one of these species. So I will select Cordia africana. The app shows different details about Cordia africana, like all the local names and their respective languages, description, ecology, use, propagation, seed treatment, management, and other details. The app also has a citizen science module where users can participate in data collection by sending information about tree species. In order to use the citizen science module, users need to press the option Take a Photo. Once in the citizen science module, users need to provide information like photo location type, is it a restoration project, is it nursery, or it's a tree survey. Location name, selected part of the tree being shown in the photo, remarks. It is important to note over here that the photo taken will be geotagged by user's current location. Once all information is provided, users can save this information for later upload.
Yeah. So these were some of the tools that CIFOR-ICRAF developed to select suitable tree species for tree planting. We have been using them for many years in the field, but we still hope to improve them further with support from partners.
Thanks, Roland and Mohammed. So I'm going to share my screen and take you through some slides of another app that we have developed at ICRAF. This is the Regreening Africa App. And basically, This is an app that we've developed building on what you just saw on the Africa Tree Finder. So with the Africa Tree Finder, you can, in the countries that it covers, you can find suitable species for planting for different types of purposes, as you saw, for specific locations. In the Regreening Africa app, we've designed an app that then allows you to plan these interventions and then track the interventions on the ground. So the idea here is that what we're doing is what we call assisted crowdsourcing for monitoring at scale. And for those of you who have been on the whole call today, you probably heard Thomas Crowther talking about sort of the bigger picture, like in terms of it not being only about planting trees, but also about land restoration in general. So this is really what I'm going to be talking about right now. And it's kind of around the recording and tracking restoration efforts. And that includes tree planting. It includes farmer-managed natural regeneration and nursery establishment and availability of planting materials. So those are the three modules in the app. And then I'll be linking it to work that we're doing with land health, overlaying the information that comes out of the app onto maps of land health indicators that allows us to look at restoration. So in the tree planting module of the app, users basically can record trees that they're planting in their in-farmer fields. So from this, we can obviously then look at what types of trees are being planted. We can determine the diversity of the trees planted, and we can look at the performance of tree planting, which is really important. So this example here is from Rwanda, where with data submitted in 2020 alone, so only in the last few months, where we have almost 500,000 trees planted as part of the Regreening Africa project, which is funded by the EU. And so in the app, not only can we look at the trees that have been planted, but we can also calculate survival rates. And we can look at what trees are being planted across different niches on farms. So whether they're planted in woodlots, home gardens, in cropped fields, internal boundaries, external boundaries, etc. And we can also look at the survival rates within these niches and really determine the success of tree planting and where we have challenges and where we need interventions to improve performance. And one thing here that you see from Rwanda in the tree planting is that we have mostly exotic species and relatively low species diversity, at least in terms of the dominant species that are being planted. So with this app, we can address this and go back to implementing partners and stakeholders on the ground and discuss how we can improve on the tree planting in terms of diversification, for example. Also in the app, the users delineate their field boundaries, and then they have the number of trees planted, the locations of the trees, as you can see on the map here. And we have then, as I mentioned, the survival of the trees. So we have this, not only have this information, but we have it in a spatially explicit way for each individual field. Another example of the use of the app is the Farmer Managed Natural Regeneration, or FMNR module. This example is from Senegal. And one of the things we notice here right away is that there's a lot more diversity in terms of FMNR than there is in tree planting relative to the example we saw from Rwanda. So here we see that a lot of the most dominant species, or most of the most dominant species, are indigenous species, so not exotics, as we saw with the tree planting. So that in itself is obviously an important insight. And again, with the FMNR, farmers record their field boundaries, and that allows us to do assessments, spatial assessments as well. In addition, we have the Nursery Module, where we track inventories within nurseries of planting materials, but also performance and quality of the seeds and the seedlings that go into this process. And the whole idea is to help the users of the app to ensure that farmers have access to quality planting materials and a wide range of species for tree planting. And so, which of course is really critical for the success of restoration efforts. In addition to the app itself, there's a data reporting system that's online and can be accessed by the users of the app, where they can look globally at what's being collected. So at the top here, we see the countries where the app is being applied or used. See, Rwanda is the dominant one in this project. And of course, this app was developed as part of a project, but it's available for anyone to use from the Google Play Store. Followed by Senegal and Kenya. And if we click on Kenya, for example, here, we then can go in and look at what types of interventions, whether it's FMNR, tree planting, etc. And we get information on number of institutions and farmers, etc., that have been doing these interventions on the ground. Now, when it also really important here, as I mentioned in the beginning, is how we can now link this information that comes from the app to spatial assessments that we do on the ground. So this is a map of Rwanda showing soil organic carbon at a resolution of 30 meters on the ground, which means that we can go down to the level of those individual polygons that you see, so those farmer fields, and extract this information. So this is based on models developed at ICRAF over more than a decade of data, systematic data collection across the global tropics. So it's based on a database with more than 200,000 soil samples from across the global tropics. And with this data, we can, by combining the spatial assessments and the maps that you see an example of here, we can apply this information, for example, for soil carbon monitoring, and also in climate neutrality goals, and for setting restoration targets, and not least, of course, for tracking restoration performance over time. Also, we gain critical insights into drivers of land degradation that allow us to more effectively target and design in the restoration, the actual sort of options that we implement on the ground. And one of the things that's really important for doing that is understanding the interactions between different processes of, for example, land degradation. And here the example is with erosion prevalence, again, at a very high spatial resolution for the different countries included in the Regreening Africa project. And then on the right-hand side, you see soil organic carbon. And by looking at the interactions between erosion and carbon, for example, we can determine, and other processes, we can determine what processes are driving carbon dynamics in these landscapes, and that allows us to then target where we need to put our interventions. So what processes in these systems do we have to somehow influence or tweak in order to obtain restoration targets, for example? So that's all on the Regreening app. Back to you, Vanya, and feel free to contact us on the email address here on this slide. Thank you.